Yes, students, today I will explain you the concept of virtual memory. The virtual memory refers to something which appears to be present but actually it is not present. Okay, the virtual memory technique actually allow the users to use the more memory for a program than the real memory of computer. If I am taking an example, like I want to run a program whose size is suppose 6 GB, but the size of the main memory of my device or my PC is 1 GB. So it is not possible to run that program, but we can run that program by dividing into the number of pages we have divided. We can divide the 6 GB program into number of pages by concept of virtual memory. So we are giving the illusion to the users that we can run that kind of program whose size is more than the size of the main memory. Now, how virtual memory is working? Actually, CPU using the concept of logical space address in your secondary storage to use the concept of virtual memory. In virtual memory, we can run the programs whose size is more than the size of main memory. How it is possible? By using page replacement. We can call only that pages which we have require now. So CPU will call only that pages which is required at a moment. The CPU will not call the whole process at the same time. The CPU will call the only that pages which are required for a moment. Clear? So that concept is called swap in and swap out. Clear? That, and it is also called the paging replacement. What is paging replacement? The CPU will call only that pages which is required at a moment, and it will be replaced by some other pages when that pages are not required. Okay, so that is swap in, swap out. So we can execute that program which is of higher length, larger length than the length of our main memory by the concept of virtual memory, which is actually not present, but we are giving illusion that we have the memory equal to the memory of the external media or the external program. Now, how CPU will execute the logical space address? By using the virtual address and the physical address. Clear? By using virtual address and physical address, the CPU can call the various pages. Okay. So how CPU will select the number of pages? How CPU will select which page to be swapped in and which page to be swapped out? On which basis the CPU will select? There are various paging replacement algorithms. On the basis of that, the CPU can replace the pages. Like we have FIFO. First one we have FIFO. What is FIFO? FIFO is first in, first out. First in, first out means the page which will enter the paging system first will be out first. So on the basis of this first in, first out paging replacement algorithm, we can execute the concept of virtual memory. We are not executing the whole program. We are calling only that pages which is required at a moment. How we are selecting that pages? On the basis of first in, first out. How it is actually working, you can see. The first in, first out is a very easy to implement. The FIFO algorithm select the page for replacement that has been in the memory the longest time. The page who spend the longest time in the memory will be replaced first. It is obvious that the page which is entering first will spend the longest time than the other. Clear? So, by example, you can see the FIFO algorithm. Consider a paging system has a capacity of 3 pages. Suppose we have a paging system which have capacity of storing 3 pages only, but I want to store the 5 pages. How we can execute that? First, in the first time you can see in the diagram, I want to store P2, I store P2. On the second time I want to store P3, I have memory, I have space, so I store P3 again. Third time I want to store again P2, which is already present in the memory. So hit is written over there because I want to swap in that page which is already present in the main memory. So I will write over hit there. And the fourth time I want to enter the page P1. So in the my paging system, the P2 and P3 is already present, P1 is not present. So I store P1. Now my capacity is full, I can't store more page. But on the fifth time you can see I want to store P5. So CPU will select that page which will be entered first. So you can see P2 is entered first, so it will be out first. So we will replace P2 by P5. You can see in your figure at the fifth time. In the sixth, I want to execute P2. So which will be I need to replace. I have in my paging system P2, P3, P1. I will replace P3 because P3 is entered before P1. Clear? So I am swapping in and swapping out the pages on the basis of their first in and first out time. Clear? So this process will go on until up to that time when the CPU required the number of pages the CPU want. Clear? So you have clarity in mind how CPU is working, how CPU is selecting the pages, how swapping in and swapping out is done, how the CPU selecting the pages they want and neglecting the pages they don't want on the basis of FIFO algorithm. The same paging replacement can also be executed by using concept of least recently used. What is least recently used? The least recently paging algorithm keep track of the pages used over a short period of time. It will be replaced that pages which is least recently used by CPU. Clear? The pages which are recently used by the CPU will not be replaced. Clear? In the example you can see, I want to, again the same example I have taken, I have a capacity of 3 pages, I can store up to 3 pages, but I want to store 5 pages. Which pages I can replace? You can see first I want to store P2 page, I have space, I store the P2, then I want to execute P3, again I have memory, I will execute it, I will store it. P2, I want to store P2, P2 is already present in the main memory, so it will be hit is written over there. Then I want to store P1, again I have memory, I can store P1. Now I want to store P5, so which page will be replaced? P2, P3 or P1? The least recently used page is P3 because you can see P2 is used at the third time, P1 is used at the fourth time, so the least recently used page is P3. So I replace P3 by P5. So I will selecting that pages to be swapped out which are least recently used. This process will be going on up to that time the CPU will assess all the pages they want to access. Clear? We are swapping out that pages which are least recently used. In this case, the last paging replacement algorithm in this PPT is optimal time. How optimal policy is working? In optimal policy will select that page whose next reference is longest. The CPU will select that pages whose next reference is longest. Why we are using these page replacement algorithms? We are using these page replacement algorithms because we don't want to execute the whole program at the same time in the main memory. So we have divided our whole program into the number of pages and we are assessing the whole process by the number of pages we want by using a concept of virtual memory. So we are giving a illusion that we have the memory equal to the memory required by the program, but actually it is not present. Clear? Hope you will get the concept of virtual memory. Thank you.